Good afternoon, sir. Good afternoon, students. How are you doing tonight?
Good afternoon, sir.
Afternoon, sir.
I'm fine.
Good. All right. Just get yourself prepared. Remember, we're moving into a new topic. Remember, your test is tonight. And don't think that I have forgotten. Somebody just exited the class a while ago when they hear me talk about tests. But we're starting a new topic tonight. So I'm just giving the persons another 2 or 3 minutes to come in. Um, and then we'll begin. All right. So just get your stuff ready and in preparation for class. All right, students. So congratulations to surviving um, one 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 unit from module 1, and we are on to our second unit in module 1. Now, as I have told you, I'm not going through unit 1, then unit 2, then unit 3. I'm looking for the big guns first so that I can get the big guns out of the way. And that's just my strategy in attacking the syllabus. I want to get the big guns out of the way first, so it is that we can have enough time to digest the information, and then the small guns now that I know can be done in a class or two, I will do last. So here goes the second of two big guns. One was indices and logarithms. I had to do indices and logarithms before I move into this other one. I need to share my screen. I had to move into indices and logarithms before I move into this one, because this one here now has powers again, powers again, powers again. So I couldn't have moved into this one before. So you notice I was at unit 4, now I'm at unit 6. And unit 6 speaks of sequences and series. Sequences and series. And of this unit, there are 3 areas. There are 3 areas in this unit. Area 1 is binomial, and area 2 is going to be arithmetic progression, and area 3 is going to be geometric progression. All right, so we have 3 areas under this to look at. Binomials that I'm hoping to finish tonight. I really want to use tonight to finish our binomials, and then we can attack the other areas as we go along. All right. So here goes. We talk about binomials. So it says from logarithms, to show you that I had to do that before, because if I had started this one here, you can say, sir, what is logarithm, sir? Right? So now that you know exactly what logarithms are, I can say to you, from logarithms, we will agree that a plus b all raised to the 0 power is 1. Do you agree with that?
Yes, sir.
Why so?
Yes, sir.
Why so? Because
Anything with the power of 0 is 1.
Thank you very much, Tantan. Excellent. I love your participation in class. You know, among others, but I really hope that everybody else will do the same. Yes. So anything at all raised to the power 0 is 1. So even if I have just a raised to the power 0, as we would have done for exponents and logarithms, by extension now for binomials, we're talking about a plus b. So we're having 2 terms in our parentheses. It no matter. Once it's raised to the power 0, it's going to be 1. And also that a plus b to the first power is just going to be equal to a plus b. Anybody remembers why I said to you that a plus b to the first power, I can get rid of it? Why am I able to drop my parentheses right here and just write a plus b? Because
anything to the power of 1 is 0.
Anything to the power of 1 is 0. Anything to the power of 1 is?
Itself.
Itself. Very good. Very good. So anything to the power of 1 is itself, not 0, but it remains itself. And the only time I'm allowed to drop the parentheses is when I have something raised to the first power. Talk truth.
Yes, sir.
Yes, sir.
So it is very good. So it is also a well-known fact from CSEC that a plus b all squares. You notice I can't just drop the powers, drop the parentheses like I did right here. So you can only drop it when you have a 1 there. All right? Only time you can drop the parentheses just so, woof, is when I have a 1. So it is a well-known fact from CSET that a plus b all squares is a squared plus 2ab plus b squares. Oh, Lord Jesus. Sir, I don't remember how we get this, sir, because if I square, so we can get a squared plus b squared. So, or you get the 2ab. All right, soon come. What if we were given the following to expand a plus b all cube, as well as a plus b to the fourth power? So we need to devise a plan, a strategy to get this thing done up. We need to devise a strategy to get this thing done up. All right. Something just comes to mind. Forgive me. Okay, mathematics curriculum. Every time I'm teaching, I have to go back to the curriculum. Let me just do the new share so it is that you can see, because I don't know if any of you have started looking at the curriculum, but so we finished all of indices and logarithm. 7 different areas. We finished those. I'm at 6. 6 has only 4 areas. This is a little shorter. So this is where I'm at. It says solve problems involving the binomial expansion. A plus b to the n where n is positive, not greater than 3. Okay, this is important. It's not greater than 3. So I will have to do questions up to 3, meaning this power is 1, 2, or 3, but nothing greater than 3. Problems involving finding the terms or the coefficient of the term of the expansion of the function, x plus b to the third power. But the students may be familiar with Pascal's triangle and notations related to NCR. It is sufficient for them to binomial coefficient 1 to 1, 1, 3, 3, 1 for examination purpose. Okay. All right. So that's fine. I just needed to get that. All right. So what if we were given to expand a plus b to the third power? And I'm going to let this stay, a plus b to the fourth power. Remember that we're not, for the purposes of this course, we're not going to do anything greater than 3. And I just showed you a while ago. So if you see I'm mistaken to give you something that is greater than 3, just say, sir, very nicely doing us. So remember, say we're supposed to only get up to 3 here. All right. So we are going to be looking at the expansion. We're going to be looking at the expansion. Be reminded that a plus b all squares. Oh, come on. All right, so I guess by now you figure that I'm actually trying to type something for you, so just be around with me a moment, please. Only trying to do this thing. All right, so a plus b all squares is a plus b all squares is the same thing as a plus b times a plus b. And watch what I'm doing here. Just refresh your memory. I know you know this. A times a, I'm using all of this to distribute over this. I'm using all of this to distribute over this. So a times a is a squares. A times a is a squares. A times b is ab. Finish with the a, I'm moving to the b now. B times a is ab. And b times b is b squares. My a square stands alone, so I write it back. AB plus AB is 2AB. Oh, come on, Mr. Shand. So AB plus AB is 2AB, and the B square stands alone, so we write the B square back. So a squared plus a plus b all squares is a squared plus 2ab plus b squares, which is what you saw right here. A plus b all cubed. Of course, you'll know that's going to be a plus b times, as I said before, whenever I see that black thing come up, it means that I am doing something here for you. A plus b all cubed is the same thing as a plus b times a plus b times a plus b all squares. But you know that a plus b all squares from up here is a squared plus 2ab plus b squares. Then I'm going to distribute it over a plus b. So watch me. Each term here is going to be distributed over this here. So watch me. A times a squares is a cubed. A times 2ab is going to be 2a squares b. A times b squares is ab squares. I'm finished with the a's. So I'm going to move on to the b. B times a squares is ab squares right here, and b times 2ab is going to be 2ab squares, which is right here, and b times b squares is b cubed, which is right here. When I'm adding, I put this 0a squared here as my placeholder, 1a cubed, I put it back, nothing to add it with. 2a squared b plus 1a squared b is 3a squared b. 1 is the same thing as 1ab plus 2ab is going to be 3ab squares, and my b cubed remains as that. All right. Now, the paper says, the syllabus says, I can one of three things. I can just tell you what the coefficients are. I can introduce it Pascal's, or I can introduce it to the NCR, which is a combination notation. I'm going to introduce it to all of them so that you are in a position that you know. I'm teaching you the topic. For those of you who are doing Cape Math, this also comes into Cape Math. And me doing this topic, when your Cape lecture comes, at least you are one topic in the battle. All right, so let's go. Are there any questions as to my derivation of my a plus b all squares to give me a squared plus 2ab plus b squares, and the derivation of a plus b all cubed to give me a cubed plus 3a squared b plus 3ab squared plus b cubed? Any questions with that?
No,
Sir,
sir.
sir,
Mm-hmm.
sir, can go up on where is the 0a3 plus 1a2b?
All
You
right, do
can
me a
start
favor.
from right there, please.
And I have no problem, Cassandra, to do that for you. But this is where I want you to do for me. This is what I want you to do for me, guys. I have no problem. I'm going to give you about 5 minutes to do this expansion for me on your own, a plus b all cubed, and then I'll come back. I want you to do the a plus b all cubed, the expansion on your own, and come back to me. There's a lovely point that I'm going to bring up. Well, I hope it's lovely. I'm going to give you 5 minutes to start for me, to do that for me, please. So start now for me. I'll come back to you, Cassandra. But I want you to start this for me, please. 5 minutes. Have we had an opportunity to do the question? So assigned?
Sir, I tried it, but I still had a problem. I didn't know how you got the second to last line.
This one here?
Yes.
All right, let's hope this helps now. Let's hope this helps. So what I'm saying to you is a plus b all cube. Oh Lord, I need to do something else. A plus b all cube is the same thing as a plus b times a plus b all squares. Do you agree with that?
Yes, sir.
But because when you're multiplying and the bases are the same, you add your powers. So this is a plus b to the first, a plus b to the second, 1 plus 2 equals 3. And then we're writing back this a plus b, writing back the a plus b. But from the line above, we have an expansion for a plus b all squares. And a plus b all squares is a squared plus 2ab plus b squares. So I wrote it back here. My question now is, I'm going to be using a plus b to distribute over a squared plus 2ab plus b squares. But I have to do it in stages. What do you mean, sir? I'm going to use the a first, and then when I finish, I'm going to use the b afterwards. So let's go. A times a squares is a cubed. A times 2ab is 2a squared b. Follow me so far?
Yes, sir.
All right, good. A times b squares is going to be ab squares, which is here, ab squares. Finish with the a's, I'm going to start with the b's. B times a squared is going to be a squared b, a squared b. B times 2ab is going to be 2ab squares, right here. And b times b squared is going to be b cubed. What you may not be seeing is, because I broke up this into two lines, normally you are accustomed to writing everything in one straight line. But it is so much easier when you line up coefficients and terms, not coefficient, but when you line up terms under each other, it is easier to do the addition. What I had here was 0a cubed, but I removed it because I recognized you were asking about it. So I removed it. Look at what we have. Look at what we have. I'm adding like terms. There's only one a cubed, so I write it back. Right, so something is kind of annoying. Sometimes I have OCD here. I like things to be very neat. So, be around with me, please. So, I have just one AB, sorry, just one A cube. So I write it back. 1a cubed. This is 2a squared b plus 1a squared b will give me 3a squared b. 1a b squared plus 2ab squares give me 3ab squares. I just have 1b cubed. I put it back. Tell me if you see that now. Hello, somebody.
So may I try see it.
Cassandra, you not see it yet?
Sir, I see it.
Yeah, man, can't stand time. Cassie, talk to me. You not see it yet?
Sir.
No.
Terry, question about the way you see it? Or you don't see it?
Yes, sir. I see
Okay.
it.
All right, Cassandra, come talk to teacher. I'm not leaving you behind. Talk to teacher. Tell me what you're not seeing.
So when you reach at the second to last one, last.
This one here?
Yes, sir.
All right, watch me, work with me. Is it the second to last one or the one with the b? B times a squared is what? Cassandra, when
A
you
square
unmute.
B. A square B.
Teacher, very good. Teacher, a squared b. Very good, honey. What is b times 2ab?
2ab square.
Magic. And what is b times b squared?
B cube.
Magic. So also lie and say you don't see it. You just tell me this in
I
the
understand now. I see no. Me never see when you go.
Jesus, man.
Me never see when you go up there. So
Come on. I'm going to can answer this something. All right, very nice. I'm happy that you're seeing it, honey. I'm happy that you're seeing it. All right. And what is important, students, is just like how she was very persistent and she's not seeing it. No, she's seen it. All right. Now, I won't do this one because they are not, we're not going up to the, I'm not going to take it out though. For those of you who want to, stress yourself a little bit more or just to put, it won't kill you if you look at this, but I won't do it. The point I was trying to bring across here is to note the coefficient. So someone fixing up this a while ago, I want you to note the coefficient. All right. So that's what I wanted you to do, to note the coefficient. And okay. So what I'm going to ask you to do for me, you're going to revise this on your own to see if you understand what and how I got here. But what is important is for you to note the coefficients here. 1, 3, 3, 1. See here, 1, 3, 3, 1. New share. Let me go back to it. Let's see what they're asking about here. Oh, come on. Oh, man. Yeah, that's what they're asking me here. 1, 3, 3, 1. The other one that I have was 1, 4, 6, 4, 1. You don't need to know the 1, 4, 6, 4, 1. What you need to know is a 1, 2, 1 and a 1, 3, 3, 1. So let me just go back to where I'm at to point out something here for you. To point out something here for you. All right, let me not do that. Let me go here, copy, and paste, and then carry this stuff. Look at oops, and then do this. All right. So I want you to note the coefficients. There is an imaginary 1 in front of that. So it's going to be 1, 1, 2, 1, 1, 2, 1. And when you do the expansion, you're going to look at the coefficients 1, 3, 3, 1, 1, 3, 3, 1. This is not on your syllabus. As I said before, they won't give you anything that is greater than 3. So, but I'm just doing the fourth one for you to show you that it's going to be. 14641. So these things are called coefficients and they are important. All right, so let's look. Let us just have a conversation now. Now that you see how I do the expansion, of course, with the exception of this one here, this is going to be your homework to figure out what is happening here. I want us to have a little conversation about this. So if we were to write the coefficients atop each other, sir, what do you mean by atop each other? What are the coefficients for this one here? Can somebody answer me, please? I'm not into it tonight.
1, 2, 1.
1 and 1.
1, 1.
So the coefficient is 1, 1. See here? And the coefficient for this is going to be 1, 2, 1. Coefficient for this one is 1, 3, 3, 1. And the coefficient here is 1, 4, 6, 4, 1. Here's one other one that I need to put here. Copy. Okay. What's the coefficient here?
1.
Very good.
1.
Very good. So I want you to note the coefficient here is 1. Note the coefficients here, 1, 1. And I want you to note the coefficients here, 1, 3, 3, 1. And let me do this. Oh, come on. No, still not helping. And then, so what is happening? So this is 1. I don't know if you can see a pyramid coming up. 1, 1, 1, 1, 2, 1. And then if you follow that, you see 1, 3, 3, 1. And you go back 1, 4, 6, 4. Can you see the pyramid forming?
Yes, sir.
All right. So okay. So work with me. All right. Good job. So if we were to write the coefficient atop each other, and that's what I mean atop each other, you're going to write this one sitting on top of this one, that's sitting on top of this, sitting on top of this, sitting on top of this. You'll be able to recognize a particular pattern. It's really a triangle, right? This was discovered by the French mathematician and philosopher named David Pascal, all right, in 1623 to 1662. Time of his birth, time of his death. His work was subsequently called the Pascal's triangle. And I want you to see figure 1 below. Now, oh man. All right, I was trying to do something to make life a little easier for you, but clearly not working with me. All right, I'll fix up this because I see where I can fix it up. All right, so look at what is happening. So if you see the 1, so picture this. 1, then 1, 1, then 1, 2, 1. This is it. 1, then 1, 1, then 1, 2, 1. And then we had a 1, 3, 3, 1. Then we had a 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 16, 50, 20, 15, 6, 1. I'm giving you these, right? But remember, we're only interested with these here. Everything beneath, we are not interested in. And I'm putting that in a different color, but it's a point I'm trying to bring across why I don't want to erase it. All right, so all of those in that color we're not interested in. We are only interested in this piece here. Now, I'm going to just show you something because I want you to see it. Anything raised to the power 0 is?
1.
1. Very good. Anything raised to the first power is?
12.
12. So we get the AA. So if you recognize, once we're talking about binomials, bi means?
2.
That's why we have two terms inside here, A plus B. You think we can have 3 terms in here?
That would be trinomial.
Ah, all right, good. So somebody had their dinner already, curry chicken and rice. Nice. So we can't have, because it's a binomial, we only have 2 something inside of the parentheses. Learn that. What you also must learn is this A and this B. Which one is written first?
A.
And which one come after?
B.
Uno not try create no mathematics. And when there's somebody them in who write the exam question, put something else in front of it so you will switch it around inside, not touch it. The first one is called question. Answer please. The first one is called
A.
And the second one is called
B.
Every single time. Every single time. All right. Now, watch what happens. What if I didn't know this? Do you think I could generate this one here from the triangle that is being formed here? How do you think I got these 2 right here?
Say add 1 then.
1 plus 1.
How do you think I got this 3?
1 plus 2.
And this 3?
1 plus 2.
No, say 2 plus 1.
2 plus 1.
Oh, I got this 15.
5 plus 10.
The 5 plus 10.
10 plus
10
10
plus
plus 5. Good. Oh, I got this 6.
3 plus 3.
3 plus 3.
I got this 6.
5 plus 1.
5 plus 1.
Okay, very good. So you see the pattern now, right? So Pascal's triangle is one very easy something you can go into the exam and you can create your own triangle right there and then in the exam. 1, 1, 1. You notice we have ones on all the way on the outside. And you appreciate this here. This took me a while to draw. You have 1, 1, 1, 1, 1 on the outside all the time. 1 on the nether outside all the time. So it's 1, starting the triangle. 1, 1. So where them get a 1 here from? Anything raised to the power 0. I wanted to put it up top here, but I was having a challenge getting it, so I said, no, leave it alone. Anything raised to the power 0 is 1 and a 1 here. Because all of these are actually representing the, what is this word? Coefficients. All right. And then now, see here, AB is 1, 1, is this 1, 1. But if you don't remember the expansion here, and for here, you can do the triangle. This 1 plus this 1 gives me this. This plus this gives me that. 2 plus 1 is 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 20 is 10 plus 10. 15 is going to be 10 plus 5. This 10 is 6 plus 4. So you can create your triangle. Your triangle is something that when I'm teaching other courses, I say to students, you must know it. After we work several questions, you're supposed to know it. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Tell me, what will be the next sequence here? 1, then?
12.
7.
The next 1, then 7, then?
6.
21.
21, then?
21.
Then?
35.
5, then?
35.
Then?
21.
21.
7.
1.
Excellent. Very good. So you guys see the trick, right? So as I said before, Pascal's triangle is no biggie. There's no biggie in doing Pascal's triangle. Absolutely no. Anybody, I mean, a baby on breast can know how to do Pascal's triangle. Trust me. Oh, incidentally, let me press pause. for those of you who, and you know yourselves, we're struggling with logarithms and exponents. We are just starting a new area. Try and make sure you catch it. Don't get lost already in this one, because it's going to be 2 units that you're going to be lost in. For those of you who are struggling, this is a new topic. A new topic. And I'm expecting that you will catch up, so that when you're revising, you just have one topic, one unit to look at. All right. Let's go. Let's go. Let's go. Let's go. All right. So Pascal's triangle is no biggie. 1, 1. And you notice what I did a while ago? I stopped and I was just sitting and looking at the screen, giving you an opportunity to look back at the triangle to say, oh, I got them just a while ago, because me never did see it. I remember when I was learning this in high school. My classmates were able to see this thing long time. I was like, what are you talking about? And I sat down, very silent, very quiet. And I said to him, oh, that them they do. He said, okay, let me catch it. So let me do it again for those of you who were like me. 1, 1, 1. This plus this gives me this. This plus this give me that. The 1 here and the 1 here give me that 1 here. This plus this give me that. This plus this give me that. The 1 here, the 1 here give me the 1 here. The 1 here, the 1 here give me the 1 here. The 1 here, the 1 here give me the 1 here. 6 plus 4 is 10. 4 plus 1 is 5. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. 1, 1, 1, 1, 1. 1, 1, 1, 1, 1. Then so you can have 2 down here, so? No. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. 1, 1, 1, 1, 1. And the same thing on the other side. All right? And that's what your Pascals look like. Now, then, sir, do I have to go remember 1, 4, 6, 4, 1 and 1, 5, 10, 10, 5, 1? No. You're only going to be remembering this up here. So up to the 3rd coefficient. And that's why I showed you on this stuff. I am only doing this here so I can show you what is happening just by extension. Just by extension. All right? Okay. So with that said, I'm going to fix up over here so a little bit. I don't like quickness. I'm going to fix up a little bit. I want us to look at a question. I tried my very best to dissect the question. I tried my very best to dissect the question, and I really hope that I did a good job. And then 2x plus 3y. Okay, I know what I did right here. So let me see how good a job I did with that one. Let's go. So you have a question. The question says, expand 2x plus 3y to the 3rd power in descending powers of x. Rock stone, sir. You introduce one term to me. No. Descending. When something descends, what happens?
It reduces.
Okay.
Or it goes down.
Very good. D for down. D for down. When something ascends, what happens?
increases or goes up.
Excellent. Excellent. So the plane is descending, right? So when I'm asking for descending powers of x, it means that go down or reduce it. So the man must say, all right, if it's descending powers of x, I'm going to start from x to the 10th, x to the 9th, x to the 8th, x to the 7th, 6, 5, 4, 3, 2, 1, 0. If they ask it in ascending powers, then it's going to be x to the 0, x to the 1, x to the 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? So just bear in mind that the last piece here, them talk about ascending powers and descending powers, is just an icing on the cake. Really, it's just a presentation. The man them peculiar, them could have said, put it in ascending powers of x. Man them could have put it in descending powers of x. And sometimes the man them say, I don't care which format they put it in, just do something. So sometimes you may see the question say, expand 2x plus 3 to the third power. Full stop. Then sir, them can say in at descending powers of x, sometimes it doesn't matter to the man then. Sometimes it does. Sometimes it doesn't. All right? Now, then sir, what if they don't ask you, but I put it in ascending powers of x? Will I get it wrong? No, you won't. And sir, what if me to put it in descending powers of x? Will you get it wrong? No, you won't. Okay, sir. Then what if they ask me to put it in ascending powers of x, but I put it in descending powers of x? Would I get it wrong? No, you won't. But you'd lose a mark for not writing it in the format that they ask you to. Can you follow where I'm going?
Yes, sir.
All right. Yes, so if you're asked for ascending powers of x, put it in ascending powers of x. If you're asked for descending powers of x, put it in descending powers of x. If they don't specify which of them, ascending or descending, put it in any one you want to put it in. If you are mixed up in your business, that make sure so you have the correct signs and terms though. All right, let's go. So if you look closely at figure 1, this we call figure 1. See figure 1 below, figure 1 here. If you look closely at figure 1, you'll recognize that as A descends or decreases, B ascends or increases. Sir, what you are talking about? All right, come. Don't quint. I want you to pay special attention, please. Put on the TikTok, put on your phone, put on a piece of chicken leg or the piece of board where you eat. Watch me. Let me even go up from here, so. So you see here, so I start with a squared, then a go down to the first power, and then b go up to the first power. And then a loses 1 power, so a go to the 0 power, and b catch the power that a loses, and b go to b squared. Anybody understand what I just said a while ago?
So go back over again.
Yeah, man, I cannot figure that. Yeah, they say not drying up a while ago, so let me see it. This one.
Like it's over the direction to wrong place.
All right, and cool. All right, let's go. A cube. A cube are going to lose 1. But every time a cube loses a power, the other term in the parentheses have to pick it up. Because at all point in time, the overall power is supposed to add up to 3. Watch this. So this is a cube. The one is a squared. So a loses a power, so b take it up. So it comes b to the first. 1 plus 2 is 3. And then when I move to the other term, a loses a power, so it becomes a. But because a loses a power, b have to take it up. So this b now move to b squared. 2 plus 1 is 3. When I move to this term, a loses a power. 1 minus 1 is 0. So a is to the 0 right here. So, and because a loses a term, b have to pick it up. So it becomes b cubed. Everybody see that now?
Yes, sir.
Yes, sir.
One more time. Watch it. A to the 4th. When this loses a power, it means the other term in the parentheses have to pick it up. So a loses a power, it becomes a cubed. And then b pick it up, so b becomes b to the 1st. 3 plus 1 gives 4, because the overall power has to be 4 at all times. When I move to the other term, a cubed loses a power, so it becomes a. See it here, so? But when it loses that power, it just don't lose a power, so you know, b have to pick it up. So B now move from B to the first to B to the second. 2 plus 2 is 4. When it goes to the other term, A loses a power, so it becomes A to the first. But best believe that B are going to pick it up. So instead of B squared, come B to the third. And this can only go one more time, because A will lose one power it has to become A to the 0. But B better take it up, so it will come B to the fourth. So if you look at the overall power, the sum of the overall power here equals to the power that we started off with. 4, 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4, and 4 stands by itself. Overall power here is 3. 3 here. 2 plus 1 is 3. 1 plus 2 is 3. 3 stands by itself. Overall power here is 2. See the 2 here? 1 plus 1 is 2, and 2 stands by itself. Overall power is 1. 1, and then 1. Overall power is 0. You know, see no power here, so? Because A is to 0. All right? So that's what I mean by you recognize that A descends, B ascends. Oh, then sir. No, me now will tell you. Can B ascend before A?
No, sir.
Why?
No, because it's always A and then B.
Very good. So A has to descend first before B can ascend. Talk truth.
Yes, sir.
Yes,
Come
sir.
on. It's like when you go to local school and they talk about dependent variable and independent variable. Talk to me, the man. Hello, somebody. Anybody knows it? Anybody knows it? Okay, so let me give you something. Y is equals to 2x plus 1. Which is the independent variable?
Why?
X. X is the independent variable. Y is the dependent variable. Because X can pick up any number. X picks up any number. Y have to transfer back and wait until X pick up the number. And then when you work it out, then Y have that corresponding number. So if we have 2x plus 1, and if we say X, if X said, I'll be at 0 today, 2 times 0 is 0 plus 1, then Y is 1. So Y have to wait until X gets his number first before him can get his number. You think Y can bright and say, oh, you know, we're a man, you're a big man. You better sit down and wait until X get a number there. So when X is 1, X is going to say, I am now 1. So I'm going to say, okay, since you're 1, I'm going to be 2 times 1 is 2, plus 1 is 3. So I'll be 3. He don't have a choice. He have to be 3. So he have to wait on X before he can get a number. So X is known as my independent variable, and Y is known as my dependent variable. So Y is depending upon the value of X for his true color to come out. All right, fast forward now. Some of our Jamaican women are independent. Oh, me now have no boyfriend or no husband to buy me nothing. Good girl work them own money. We want an X6, you go buy me X6. You think you go upon you for no, brethren, go about your business. Me want to buy 10 pairs of shoes today, I am gonna buy it. Because she is independent. She ain't depending on no guy to come and do the stuff. All right? And I'll come back to this conversation when I move into functions. Because functions kind of mix up, you know. Function come like, I want to call it pink wall and them something. When they can't go get the sauce, yeah man, functions just, oh, I have to be careful of functions here. Functions will carry a prison. But you have to recognize though that when you look at your equations, your X is going to be your independent variable and your Y is your dependent variable. All right, so Y depends on the value of X, so it is that I can put it into it and work it out and then make whatever come out. That's what Y have to be. All right, so watch this now. So yes, you're correct. So A has to descend first before Y can ascend. Now remember, I said to you, when you have them something in the bracket, not change them, because whichever one right first are the one they are A. When you change it wrong, it means that you change the value of A. So they get bright and say, oh, I didn't want to work with a negative sign first, so that's why I did just change it around and put in. If them here -1 plus 2x. The change around people them something and say 2x minus 1. But sir, isn't it the same thing? Yeah, are the same something, you know. But right about now is that you change the value of a. A is no longer -1. You change a to be 2x. Problem. Big problem, sir? Not necessarily, because you know, say -1 plus 2x is the same thing as 2x minus 1. But how the answer is going to be written is where the problem lies. So anything them right first is A. Anything them right after a B. Always recognize what the power will be. Let me tell you a secret. The man them not, you know, they say, we want to catch one question. Where them are going to give something with the power 2. You see, because them say, well, if we go greater than 3, any question them give, I'll go back to the third power. Because the one to the second power way too easy to work. And them are going to give you 5 marks. So the one with the third power, them are going to give you. Or you know that, sir? I sense it into my being. All right. So let us continue. This is what I'm doing. I wrote these notes so you know. And I'm now dissecting the notes. So therefore, in a similar fashion, in the expansion of 2x plus 3y to the third, the same question up here. So one variable x will descend that 1 year, while the other variable y will ascend that 1 year. So this has to descend first before the one ascend. The one you have to give up something before the one accept it. The two of them work as partners. Husband can't pay the light bill. Why I say no worry about it, babes. I will pay it. Husband can't pay the mortgage. Here's the plan, you know, so we can give half of it now. So them work together as a team. All right. Any questions so far?
No, sir.
No,
All right.
sir.
All right, good job. Let's go. Nikki,
Yes, sir.
how you stay?
All right.
All right, good. Shanti, you good?
Yes, sir. No question.
All right, good. Rockstone. Alvarango. Unmute for me, please, dearest. Oh no, your internet is bad. Mute for me, honey bunches. If you hear me, mute for me if you hear me. All right, unmute again now, please. Denise, unmute again for me, please. You hear me better now? Can you speak? Let me hear.
Sir, I've been unmuted. Sir,
No,
it's
madam.
lagging.
Huh? What she say about it, guys?
Didn't hear, sir.
Didn't hear,
Yeah.
sir.
Alvarango, say it again,
She
honey.
said she just log in.
Yeah, but you weren't at last class, Denise. All right. You know what I'm recognizing, guys? Forgive me, I have to stop and say, I'm going through my list. And I'm seeing some students who, yeah, just one student right away. I'm not so familiar with the name, but anyhow, all right. I need to get a true class list for this group. All right. So that is the coefficient of the cubic power is given by 1331. Sir, how we know that? See it here, so 1331. This has been tested, proven, and tried. 1331. All right, let's go. So in using Pascal's, that 1331 here, so very important. Very, very important. It's like you go into KFC and ask for the honey mustard sauce. If you're not eating the honey mustard sauce with the KFC, you're not eating KFC. You're only eating C. Let's go. Watch me. How many terms do you think I'm going to have?
Sir,
4, sir.
Why 4?
4 coefficients.
Excellent. You see what I'm asking? And I don't want anybody to say to themselves in fully, duh, and a 4. I'm asking because I want you to see some of the obvious stuff. So when I'm speaking, these are the patterns and the trends that I'm actually trying to highlight. I can't have 5 because I have only 4 coefficients. Uh-oh. What power am I in? What power am I in? Can somebody say 3, please?
Cubic 3.
Very good. The cubic power, which is the third power. Now, the second term from the front or the back tells me what power I'm in. This one means that I'm in the 5th power. I can go from the back or I can go from the front. So the second one tells me the power that I'm in. So the one is a 5, it means that I'm in the 5th power. See, we go from the back to 6th power. The one here, the 6th power, come and go from the back. The second one from the back tells me the power. The second one from the front tells me the power. The second one from the front tells me the power. So I'm in the 3rd power or cubic from the back. This is the 4th one. So look at the second one and it tells you what power, the highest power you're in. So like one that go to the 5th power, the second term tells you. Why I couldn't use the first term? Because all of the first is 1 and all of the last one is 1. So it's the next term you have to look at to tell you what power you're in. So when I say 1, 3, 3, 1, it means that I'm in the 3rd power. But watch this other thing that I need to point out to you. I'm in the 3rd power, but I have how many coefficients?
4.
I'm in the 5th. I'm in the 4th power, but how many coefficients?
5.
I'm in the 5th power, but how many coefficients?
6.
And the 6th power, and how many coefficients?
7.
Good. So I have 1 more coefficient than the power that I'm in. True or false?
True.
Right, very good. So I'm saying to you, students, I am actually pointing out the obvious. Lucky, when I was going to school, teacher never point out them something to me. I have to sit down and point it out to myself. But though it is that is a different era and time of learning that we're learning online, and because we're going to get the very best experience with me online. I'm showing you all the tricks and the trades. Let me just press pause here. And there's a reason why I'm pressing pause now. I can go through this and finish this long time, but I want to take my time so that this thing can percolate into your brain spaces. All right. Let me just ask one question before we move back. We jump back into it. Are you enjoying, and I'm particular with the choice of words. Are you enjoying my online classes? Are you, yeah, let me get part first. Are you enjoying the math classes, the online classes?
Yes. Yes, sir.
Yes, sir.
Yes, sir.
You're learning?
Yes, sir.
Yes, sir.
All right. All right. Put it this way now. All right. Thanks for those who answer. I'm going to ask the question another way. Don't believe that if you answer me honestly, you're going to lose mark in your test. No. Is there anybody who, when you're going with on this online something and you can't take it? Let me see you. Talk to me. Is there anybody in the class who feels why this class is going way over them because they now learn online?
Sir, I wouldn't say that. It's
Okay.
just that if I don't I understand in class, but then if I leave class, I don't understand. So I just watch the recordings because the way you teach is easy to understand, at least for me.
Okay, thank you, Tantan.
Same.
Okay, great. So in my own reflections, based on what Tantan said a while ago, is what I have been reflecting on. When I was going to school and I miss a class, members say I miss the class because there's no recording, and you go to your friend and say, well, teacher, all him talk about is just binomials and in 1, 3, 3, 1, done. They're not telling the other little nitty-gritty stuff we are going on, but I'm very consistent, and I'm not being conceited, but I'm very consistent in posting your notes and posting your recordings within 24 hours. True or false?
True. True.
So nobody can complain and say, we're not getting the recording or we're not. But it's important, students, that you go through the recording. Even if you believe that you understand, there may be something that you can say, blow, sir, they say, yeah, man. So I really want you guys to use this opportunity. This is all that we have right about now. All that we have right about now. And I want you to maximize on this experience. Maximize on it. We're going to use all the channels possible. And this is just because we're in a family. I'm just saying this to you. I'm not sure boasting, but I thought to myself, one of my students, somebody like you, went up recently and said, sir, say, I'm going to make a little quick move. I say, serious? He said, do me a favor. If I buy something, you can carry it back for me? He said, sure, sir. And I bought 2 more gadgets for my online teaching and learning so that the experience is even more real for you. One of them I'm using now. The other one, I soon bust it. I mean, we try it out already, it worked nice, but we soon bust it. Just like how I'm writing on screen with the stuff, I can write on this other stuff that you can see what I'm doing. Now, one of these nights, I'm gonna maybe Friday, all being well, I'll just set it up and then we can just do it like that. But if I do it like that, it means that you're not going to get the notes per se, because it means that I've been writing in class. So you'll have to go and screenshot your stuff now in order to capture those notes. All right. But I'm saying this to say to you that because I recognize that this is all that we have for now, and that life goes on. The coronavirus just make a press pause on life. Life still goes on. Life is continuous, right? You hear me talk about continuous functions when we move on to calculus. So life continues. So therefore, I'm investing in trying to bring across to you. I'm invested in technologies so that I can bring across to you more effectively and efficiently. So I'm going to beg of you. I want Ono to learn. That is the only thing I'm going to ask you to do, just to learn. All right? Okay. Fair enough. And thanks again, Tantan, because that's what I was going to say to you earlier. You took the words right out of my mouth. If you join the class late, don't get frustrated. Just try to pick up on what is happening, because the recording is always there. And what I don't do is to send a recording in the WhatsApp group and then everybody can say, sir, you can't send back the recording because my phone can't take it. I'm sending you to a place to find it. So all of you have access to the YouTube channel. Use it and use it well. Those who follow these words and this tune up this voice are the ones who will get your distinctions. All right, let's go. So having just pointed out to you then that the second one, you know what, I'm going to tell another story. You see these up here, they're called palindromes. Palindromes. Look here, 1, 6, 15, 20, 15, 6, 1. Reverse. 1, 6, 15, 20, 15, 6, 1. 1, 3, 3, 1. 1, 3, 3, 1. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5. It doesn't matter where I go. It doesn't matter if I start from the left to the right or right to the left, I get the same number. Can you see that?
Yes, sir.
Spell race car for me. Somebody. Anybody?
Sir, seriously?
Tantan, don't cut me short. Just spell Tantan, spell race car for me.
Race car.
Yeah, race car, yeah.
RACECAR.
All right, spell it backwards now.
RAC.
Right. Wow. So that's the point Tantan was trying to make. I wasn't trying to be cheeky on the bunch too. Tantan says, sir, like, are you serious? All right, let me just, oh Lord, what am I doing here now? The point I'm making here is, come on. point I'm making here is RACECAR. So race car is spelled this way. But if I go this way, RACECAR, I get race car that way also. Can you see that?
Yes, sir.
Yes,
So
sir.
it's called a palindrome, right? Level, L-E-V-E-L is one way again. So L-E-V-E-L, L-E-V-E-L. So whichever way I read it, I'm going to get the same thing. So we'll call those palindromes, right? So it really doesn't matter which direction you're going. That's the point I was trying to make. Wasn't trying to be cheeky, not today. All right. So the second letter, just like in race car, the second letter, because the first letters will be the same. The second letter tells me what it is. It says that. See there, the second letter, not second letter in here. Second digit here will tell me what power I'm in. All right. Let's go. So remember, A descends while B ascends. A descends while B ascends. Watch me. So I'm going to write 1. See here, so. A is 2x. See here, so. 2x to the third power. And this 3y is going to be the 0 power. This plus this must be equal to the overall power. Everybody see that?
Yes, sir.
Did I have to write this 3y to the 0?
Yes.
Why?
No,
Because?
because anything with 2 of 0 is 1.
Very good. No. Someone will catch it, you know. When we say someone will catch it long time, and that's very good. All right? Okay. No. So that's the first term. The next term, so I finish with this one here now, because remember it says binomial, so it has 2 something. So the coefficient plus the 2 something then. So the second term, the second coefficient rather is going to be 3 plus 3. Then, sir, a plus, I got plus everything every time, every time. If there's a negative sign inside of it, the negative sign will come out. If the negative sign inside of it, the negative sign will come out. What do you mean come out, sir? Don't worry about it. When I get there, I'll show you. Watch this now. This is 2x to the third power. Remember, say A I got this. A descends, B ascends. So A is going to descend, means that A is going to lose 1. So this now, the next term is going to be 2x to the second power. See it right here, so 2x to the second power. And then B is going to ascend. So now we're going to have 3y to the first. Magic. 3y to the first. Then I'm going to move to, and look, check. You need to check every time, you know. 2 plus 1 is 3. All right. Then I move into the third coefficient, which is another 3. And you're not going to look on this, you know, you're going to look on the preceding term. So if these are 2x to the second, that means the next one's supposed to be 2x to the first. And if this is 3y to the first, that means the next one's supposed to be 3y to the second. Because when this one descends, this descends to 2x to the first, that means that y is going to ascend it, moving from 3y to the first to 3y to the second. Then it went plus the last coefficient, this. If this is 2x to the first, that means when it descends, it's going to become 2x to the 0, right here, so. And then this 3y to the second is going to ascend to 3y to the third. See it right here, so. Pascal's done right here, so. If you follow me, it's done right here, so. And all you have to do now is just little school mathematics, algebra, to fix it up. Sir, you can do it again. Thank you for asking. When A descends, B ascends. When A descends, B ascends. Watch me. I will start off with the big something A and with the overall power. So if this was 5, them not give 5, but if it was 5, it would have been 2x to the 5th that we start off with, right? So we're going to use this and start off with the big number up top. All right, watch me. So this is 2x A to the third. That means so y do have nowhere to go now. Y can't go nowhere because the overall power is 3. So y can't go nowhere. Y have a turn 20. Oh, so that's why I have it as 0, sir. Yeah. Then, sir, what if I don't write it? No problem. Not a problem. My second coefficient is 3. And then I'm going to have 2x to the second power because A ascends and B ascends. A descends and B ascends. So when A descends, this will become 2x to the second power. See it right here, so? But B is going to ascend to 3x to the 3y to the first. Right here, so. And then the overall power is supposed to be equal to 3. 2 plus 1 is 3. Then you move to the third coefficient, which is 3 here. Bam, you write it back. Then you look at this and know that this moved from 2x to the second. That means we're going to lose one now, sir. So you're going to be 2x to the first. See it right here, sir? You are correct. But because A loses, what B have to take it up. So this now move from 3y to the first to 3y to the second. And 1 plus 2 is equals to 3. Sir, I'm following you. I'm happy. Watch this now. This one here is this one. And if this is 2x to the first, that means that when it lose one, it will become 2x to the 0. See it right here, sir? Then, sir, we have to write it. You don't have to write it because you know it's 2x to the 0 and anything raised to the power 0 is 1. And then again, because it loses 1 from here, y has to take it up. So it's going to become 3y to the third. See it right here, sir? And when you finish, write this. This is what I normally do. Because when you're going on the exam, you know, they're looking for something, you know, you don't lose marks or them things here. Eh? You're going to the exam and there are other areas where you are more likely to make mistakes. You don't make mistakes with them for something here. So you can double check. Watch me. This is what I normally do. I normally do a 3-prong check. And these 3-prong checks are pretty quick and easy. So I write on my coefficient, I check to see I have my coefficient. 1, 3, 3, 1. First check out. 2, I look at my A. My A is 2x, and I'm starting off to the third. 2x to the third, 2x to the second, 2x to the first, 2x to the 0. Second check done. My third check is my B. My B is 3y. 3y to the 0, 3y to the first, 3y to the second, 3y to the third. You can't get it wrong. Or if you get it wrong, and you don't write it out and then you do your check. 3-prong coefficient, your A value, your B value. Good to go. So if you pay close attention, you'll realize that 2x raised to the third power decreases each time until it raises to the 0 power for the last term. Okay, my computer don't want to type it. All right. And recall that anything raised to the power 0 results in 1. All right, just remember that. You know this. A similar observation arises when 3y to the 0. The expansion continues until it reaches the maximum power of the expansion. Remember, you know, it's a maximum power of the expansion that we're talking about, you know. So every time 3 plus 0 is 3, 2 plus 1 is 3, 1 plus 2 is 3, and 0 plus 3 is 3. So every time the sum of the power is supposed to be equal to the overall power. Please also note that the sum of the powers, them one here, bam, bam, must be equal to the overall power. Bam. Very important. All right. Now, so when I apply Pascal, so you see all of this when I write here, so all of this, but come back and write it down here, so all of this here, so trust me. Let me spotlight you. So all of this here is the same thing right here, so your teacher is ready to work the question. All of what I gave you right here, up top here, all of what I gave you was just explanation as to what it is that we're doing. So here's the application of Pascal. So we know this up to this point. We're going to evaluate it now. Anything raised to the power 0 is 1, so that goes to 1. That one is this one. You notice I have not evaluated my coefficients just yet. I'm just evaluating the parentheses. 2x to the third power is going to be 8x cubed. Remember, everything in the parentheses will be affected by this 3, not just the x, but the 2 also. Everything in the parentheses will be affected by my power. So this is 2 raised to the third power and x raised to the third power. So 2x times 2x is 4x squared times another 2x is 8x cubed. So see yourself? But let's write the 8x cubed in the brackets right here. This is 1, as I told you. This 3 is this 3 here. And 2x squared is going to be 2x times 2x is 4x squared right here. So. And this 3y to the first power, remember, so when it is written to the first power, we can just drop it and just write by the 3y, see it right here. So only when it is written to the first power. Please do not misrepresent me and say something to the third power or second power and say, sir, so we can drop it. That will not be correct. Only when it is numero uno, number 1. And then no, this 3 is this 3. And again, we have 2x to the first, which is simply 2x. Then we have 3y to the second power. 3y to the second power is going to be 3y times 3y, which is 9y squared. See it right in here. So the 1 here is this 1. Anything raised to the power 0 is 1. And nobody write that, that's a 1. 3y cubed is 3y times 3y times 3y, or 3 to the third power is 27 and y cubed, 27y cubed. And then 1 times 8x cubed is 8x cubed. And then 3 times 4 is 12, and 12 times 3 is 36, and x squared y, see it right here, so. And 3 times 2 is 6, and 6 times 9 is 54, see it right here, so. And x times y squared is xy squared, see it right here, so. And 1 times 27 is 27, see it here, so. And the y cube is here, so, right here, so. Bam, answer. So the question did ask us to write this in descending powers of x. Let us check to see if it's in descending powers of x. X cubed, then x squared, then x to the 0. Yeah, it is correct. Are there any questions so far? Are there any questions so far?
No, sir.
All right.
Yes, sir.
Natalia. How is it tonight?
I'm not sure. I'm not supposed to go back over it when I send it not again.
So I'm going to ask a while ago if everybody's understanding. You never say something to me.
Sir, how you get the 54 again?
3 times 2 is 6, and 6 times 9 is 54. I'm multiplying the numbers.
I see now.
Yeah, good. All right. So I'm giving you a chance to just look at the calculations again while I just clear my thoughts in something here. All right, students. I sound like a broken record, but I'm going to forever say it because I mean it. Funny enough, I'm team leader for STEM. And whenever I meet with my staff and I ask them, how is it going? Oh Lord, Mr. Shanti, in class, I am asking the students to unmute to talk, and they won't talk. And I don't even know. And I said, but to call them and say, Mr. Shanti, I'm not unmuting them that way. And we know that they're there. I said, okay. And I speak to one lecturer, and I speak to another lecturer, and another lecturer, and everybody has the same thing to say. Again, put it out there. Quite a number of you are moving on to the university next year. For those of you who have intentions going there, those of you who will stay back with us for other programs of study, you may be a little better off, so to speak. But for those of you who are going to go to other tertiary institutions, I'm going to tell you, Excessive community college is tertiary. But it's like when Mr. Shan will stop the class and just encourage you and will come and say, no man, are you understanding? He said the man them up at the university lecturers them want to finish them syllabus. So the man them will teach. If you don't catch it, go to the library.
Sir,
Yes, Papa.
for them people that will go up at university, like when me can ask you to explain back over something, or tell you, say, me not understand, me can ask them same question.
Not in the man them lecture, you're bright. Hey, brethren, you know, so one time I just left high school, you know, in our maths class, and now understand something, I put up my hand in the class. Till it just showed me. That's why we have a tutorial class, no questions. I was like, Matthew, the class was in the interfaculty lecture theater, one of the largest lecture theaters in science tech. Well, my days of university was Faculty of Pure and Applied Sciences. It's about 300 people in the class from all schools. You know, sometimes they talk, oh, I went to KC and I went to JC and I went to Immaculate and I went to Campion. And you may say, oh, I went to Tivoli. When you go to university, the whole are in the same class. So no school no better than none, right? So when people talk about, oh, my school better than yours, it don't mean anything to me. I see it when they go to university and some of the students who come from the little inner city school outperform some of the students who come from the top-notch schools. Trust me on that. When you get there, you can say, sir, didn't know him at all. Well, trust me, I've been there and I see it, right? And the man shame me. And the whole interfaculty laugh, ashamed, me not asking more questions. So we have to go into your tutorial session now. And so by the time we reach the tutorial session, a couple of days later, the question that you had, gone. Literally gone. And you know, one of the things again, I remember asking, wasn't understanding something and go up to one of the offices and see one door open and knock and ask one of the doctor person, excuse me, can you explain this to me? And the woman looked at me and said, I don't teach physical chemistry. I'm an organic chemistry lecturer. I said, thank you. Turned my tail and she said, come here. Let me see the question. And I showed her the question and she answered me. Do you understand? Thank you very much. Yes, I do. Don't understand one thing she said to me. Because already there, sir, when she rushed me, she blocked me. So there is nothing I could understand what she explained thereafter. So the point I'm making is the community college system, even though we're tertiary, we really take time with UNO and go through the stuff and may stop and say, UNO understand, but I don't want you guys to think that this is how it's going to always be. When I went to the university, I had a shock of my life. The shock of my life because I thought it was high school. You know, I'm going to one class, I miss one class and say, yeah, try that to university and see if you can pass the course. Because I recognize that 3 topics demand in one class, right? So I'm saying to you students, get into the habit of start asking your questions and participating in class, because when you move on to the other places, you're going to have the shock of your lives. All right, let's go. I have another question here for you though. It says, write the expansion of 2x plus 3y to the 3rd power in ascending powers of x. But sir, 2x plus 3y to the 3rd? No, the same question we just did a while ago. Yeah. But what did they give you that question? And instead of putting ascending, they put descending. What instead if they put descending, they put ascending. How would you write your answer from here? So this is the answer that we got. But they want it in ascending powers of x. What would you do?
So just turn the answer back for you.
Same way, so. Like easy 1, 2, 3. Instead of 27y cubed here, watch it. Eat this. Instead of positive 54x squared y, xy squared is so, see it so. Instead of 1 here so, see it right here so. And the first one, it turn last. So what we do, we lift it up from here so, and just boom, and just flip it around. Right? So it's important that you see what is happening, because sometimes, you know, and that's why I said to you, do not interchange this 3y and put up here so, and this 2x and put down here so. Don't get into the habit of doing that. Don't. You get yourself into trouble. So just look at what it is, do the expansion, and then as your final check to see if it's in descending powers. If the man wants it in ascending powers, just flip it. The only other caution I'll say to you is, make sure that when you flip it this side, because if this were a negative 27y squared, don't care to put positive 27y squared, carry the sign with it. So you put negative 27y, not y squared, y cubed, negative 27y cubed, support and so on. So carry the signs with it. Don't leave the signs alone. And once you do that, guys, you're good to go. Good to go. All right, I wrote some other questions, and that's why I flipped back a while ago, because these questions here are with the coefficients greater than 3. And then it says, this one here is what I just did. And then I have this one here to give, but I'm not going to give you that one yet because that one have fraction in there and I don't want to shock you just yet, which is this one here. I did that one. And then I'm moving into the combination notation. The combination notation, remember I gave you something with NCR? Not gave you. I showed you something with NCR on the syllabus. See here, NCR. So I'm going to show you the NCR because I did say to you, they said that we can just give you the Pascals. I want to make sure that you are with me. I can just give you the Pascals, but I said, no, I'm going to give you all the methods, and then you can choose which one you're most comfortable with. So it says, while the students may become familiar with Pascal's triangle and notations relating to NCR, which is an N choose R, it is sufficient to know the binomial expansion 121 and 1331 for examination purposes. So I'm showing the Pascals. Everybody likes Pascals. Pascals is easy. But I still want to show you the binomial coefficient, not the binomial coefficient, the combination notation, right? So I'm going to show you this method also, and then you can choose. Really and truly, if I were only going to be teaching you Pascals, I would say that 6.1 is now done. I'm finished with all of this now. All of this here, I'm finished with, right? This here, the other piece here, and see that that's a new module. I may move into this module next, but anyhow, this module, it says identify arithmetic and geometric progression, evaluate a term for an AP/GP, and determine the sum to infinity. So this is pretty easy, pretty easy. This here is really not difficult, all right? So what I'm going to give you to do for me is, because I gave you this ax plus b to the third power, I want to give you something. Nah, I just did something to the third power a while ago. Let me give you, ouch. Let me generate something here for you. Let me generate something there for you. I'm going to generate a classwork for you. I'm going to ask you to take out the classwork that I'm giving you here. I'm going to project what it is that all right. So I'm generating this here. Obtain the expansion, oh Lord, help me. Obtain the expansion of 3x plus 4 to the third power in descending powers of x. In descending powers of x. And then I want you to write off that question for me. And then I'm going to do the answer. So just take a picture of this or something. I want these two. I want these two to be done now. I'm going to do the solutions, correct these solutions here. So take off these two so that I can project for you. The question that we just did. All right, so let me know when you have taken off these two questions, please.
Sir, I can check your inbox, please.
Sure, honey bunches. Oh Lord, I have 16 messages. Why Mr. Sean don't learn to read in chat when I'm teaching a class? Okay. Oh no. Oh, okay, because your internet was is in and out. Because I was trying to have a conversation with you earlier. All right, so I'm just seeing that. Tarek, no, I won't ask you to do up to the third power. Oh, yes, I was asking you to do that one. So it is that we can generate the coefficients for that. Yeah. Amelia, pray for me. Pray for your teacher. All right, Danny, you need to check your internet here because I think it's very unstable. So you need to check your internet access. Are you using Wi-Fi or using data? John Mark, you're mean. All right, can somebody put the YouTube channel in the thing again, please, for Kanisha? She needs it. Please and thanks. Okay, so Dan, you're understanding. Very good. Oh, I know it. I know that it was data. All right, Dan. Me and you will talk after class here. Well, maybe not after class tonight, depending on how we feel. But we're going to talk. Yeah, I know. I hear it. When I asked you to unmute, you were going in and out, in and out. So I kind of figure out. All right. When is I'm supposed to check my inbox? Is it WhatsApp or the chat?
So WhatsApp.
Okay. All right. So since nobody's talking to me just yet, I am going to be sharing. I'm assuming that you've written out the question, and I am now going to. All right. So this is where you're going to start. So when you watch me, when you're doing the question, you see all of what I did up here, so was just formality of explaining what is happening. So I now want you to do 3x plus 4y to the third power. You're going to start it. So see something up here, so start for me, please. I'm giving you, it's now 7:35. It's the first question on your own. I'm going to give about 7 minutes. 1, 2, 3, about 7 minutes. Between 5 and 7 minutes. So start working. Always stay. Okay, I'm seeing some things coming in.
So we must send you.
Say it again.
We must send you the answers.
Not quite, you know, because you know that your teacher sitting right here in front of the computer, and because I didn't want to move the screen, I didn't get the chance to do my own calculation. You know, let me do it now. It shouldn't take long in typing. So, what are the coefficients again for that one? Is it 14641 or 1331?
1331.
131.
Job 1331, and then this is going to be 3x to the third, and then that's just going to be 3 times 3x to the second, 4y to the first, and this is going to be another 3x to the first, 4y to the second, and then this is going to be 1, 3x to the 0, 4y to the third, and that term goes to 0. Are you agreeing with this line here, Taham?
Yes, sir.
Yes, sir.
And then I'm going to have 3 3 is 9, 3 to the 3, x to the 3. I'm just going to do that how I had it here so you can see it. And then that's going to be another, that's going to be 3, and that's going to be 3 to the, interesting. That's 9x squared, 9x squared. All right, I'm going to address a class on a matter here that I just got trivial of 3x to the first, 4 for 16y squares, and then no, that's going to be, just check to make sure that I have the same thing that you have here, because you're a good teacher, me just very well. 4 for 16, 64y cube, and then I'm deleting that. And 3 3 is 9 and 3 is 27. 27x to the third. 3 9 is 27. X squared. Oh, 27 times 4 is how much? 108?
Yes, sir.
Yes, sir.
108x squared. Y. And 16 times 3 is
144.
say it again, 144?
Yes, sir.
And that's xy squared. And that's 64 y cubed. Tell me if you agree with that.
Yes,
Yes,
sir.
sir.
All right. Very good. Now, so I read a message that and I kind of sense it from before, and that's why I keep stopping the class. So I kind of sense it before, that's why I keep stopping. We're supposed to go to the third call. That's why I kept stopping the class and asking a question. So some people are feeling that because they're not understanding and because they have stopped me more than once to ask me to explain, that they don't want to be annoying me. Hello, that's what I'm being paid for, right? So any of you believe that you're annoying me by saying to me, sir, I'm not understanding, I think you have it wrong. This is my job. This is what I've been paid for these many years. I'm a team leader. And if any of my students come to me and say, sir, I'm in such and such a class, and I'm asking a question, and the teacher says that you are annoying me because look how much time I explain it. And no, something wrong with you. No. Let me know, because I will deal with that person. It is my responsibility to go through so that you can understand. If I believe that you are holding back the class because after my multiple explanations, you are still not understanding, it then becomes my responsibility to say to you, meet me outside of class. And I will set up something based on my schedule. Let's hope that you can fit into it so we can go through the areas that you're having a difficulty with. It is irresponsible of you to sit down and not understand and not say nothing. Let me tell you that you are annoying me. You don't assume that you are annoying me. Let me tell you. All right? So I'm going to say it again. If you're not following me, stop me. If you're feeling that you are stopping me too often, send me a message. Bring it to my attention, sir. I'm sending a message in the WhatsApp group, and then we have a conversation in the WhatsApp group, and then we take it outside of the WhatsApp group, and then we can put something in place. My aim is for you guys to do very well. Please. There's going to come a point, students. Every class we have, I'm telling you the same thing. There's going to come a point where I stop asking you if you're understanding, because you are no children. You're big people, and you have to take responsibility for your own learning. So there's going to come a time when I just going to teach, and I'm now going to ask, are you understanding? Shante, unmute and answer me, please. Tenil, no, never stop it. And then I'm going to sit if you do not talk to me. All right, please. I can come here and I tell my Saturday group one Saturday morning, me come out of my good bed, 8 o'clock, and I teach and everybody sit down there very comfortable. I said, no. I said, there is no water or macro in my bed. And if I want, I could sit on my bed and talk the maths. I know this maths. I know it. So I want you to talk to me. All right? Okay. I get that set. All right. Numero dos. All right. I think I made a boo-boo with this topic.
Wait, sir.
Yes, honey bunches. That's not what you give it the answer?
No. For number one,
because
I was waiting on you.
Go ahead.
I understand up until the part where the numbers are in color, right there. Yeah.
Right here, so? All right.
Second line.
The second line right here, so?
Yeah.
Right here. All right, don't worry about it. Anyway, Tantan.
Yes, sir.
You can't find me them with here because when they called me so a while ago, I feel like I understand something, Yes, Tati.
So why didn't you put the 4y in the first equation, like 1/3 x squared bracket 4y?
Hold on, I lost. Hold on. Let me find it. Where are you? Right here?
Sir, the first part of the equation. Why didn't you put like a 4y?
Right here, so?
Yes, sir.
I could. You know me nothing. I could. Since you asked me, let me do it. It's not gonna change. It's not gonna change nothing, mommy. But again, do it. But 4y to what though? What point are going to be raised to?
To 0.
Okay. Yeah. All right. Yeah. So you get it. Yeah.
So I just like to see it's like
No problem, honey bunches. Anything for you. So you all right now, right there, so right?
Yes, sir.
All right. Oh Jesus, who was it now? Oh, right. I just had a senior moment. Let me just check to see. I had a senior moment just now.
Sir.
Yes. Yeah. Tanisha. Each one. Yeah. Go ahead, please.
Sorry, Channel, not Ichman. But
No, man, I said that Ichman was the one who spoke to me earlier, so I wanted to answer her. But go ahead, Shan.
oh, sorry. So I used the example with the ABC, the AB to the third power, sir, where you did the AB squared and then you multiplied it to a single AB, sir. So that's what I used to do this question, sir, and I got nothing like that whatsoever. Even though it was kind of confusing still, but I still never get none close to it.
That's fine. Don't worry, that's fine. So Hitchman, come between. Let's go. So I want the pair of you to keep your microphones open as long as you don't have any disturbance in the background, so you can talk to me. And the rest of you too, you can talk. Let's go. So you're given the question 3x plus 4y to the third power. And we're using the coefficients 1, 3, 3, 1. Why, sir? Because it is raised to the third power. Do you agree with this line?
Yes, sir.
All right, good. Now, do you agree with me having 1 here?
Wait, sir.
Yes, honey.
Sir, so because it is raised to the third power, the coefficients are 1, 2, 3, 1.
Absolutely.
So that is what it is going to be like all the time?
Every single time. Today, tomorrow, and the day after that. Remember, sir said the second digit in the coefficients tells me what power I'm in. The second digit in the coefficients, either from the left or from the right, tells me what power I'm in. If it was 4, see, 1, 4, 6, 4, 1. So the second power tells me what power I'm in. So anytime you get anything raised to the third power, best believe that you're going to use 1, 3, 3, 1. Trust me. All right? And then now, when A descends, B ascends. Which one is A?
X.
3x. And which one is B?
The 4y.
4y.
Very good. All right, so let's go. So this one is this one here. And then no, A is 3x. So I'm going to have 3x raised to the maximum power, which is 3. And then no, this 4y is raised to the 0 power. Because when I add my powers, I'm supposed to get back the overall power here. I've finished with the first term. The second term now has coefficient 3 right here. And because I have to reduce it by 1, so if this is 3x to the third, that means the next term is supposed to be 3x to the second. And because I reduce this by 1, it means that my 4y now, which is in the B position, must be increased by 1. How you know that, sir? If this is 4y to the 0, that means this has to be 4y to the first power. Let us check the overall power, sir. 2 plus 1 is 3. So now I've finished with my 2 terms. I'm going to go with the third term. The coefficient here is 3, so I'm writing the 3 right here. And look at the term here, A. A is 3x to the second power. That means for this one, it has to be 3x to the first power. And when I look at my second term, I have 4y to the second power. 4y to the first power. That means this one now has to be 4y to the second power. Let us check our coefficients, or powers. 1 plus 2 is equals to 3. Then I reach the last term. This one is this one here. Now, if this is 3x to the first, that means the other one is going to be 3x to the 0. And if this is 3x to the 0, that means this has to be 4x to the third. Why, sir? Because 0 plus a number must be equal to 3. The number must be 3. If 0 plus a number is supposed to be equal to the overall power, that means this number is supposed to be 3. So let me check now to see if when A descends, A ascends, B ascends. 3x to the third, 3x to the second, 3x to the first, 3x to the 0. Check. 4y to the 0, 4y to the first, 4y to the second, 4y to the third. Check. Coefficients 1, 3, 3, 1. 1, 3, 3, 1. So you have 3 points in which to double check your answer. 1, the coefficients. 2, the A's when A descends. And then 3, when B ascends. Once you've checked that, you're good to go. The next thing to do now is to evaluate here. So I was showing you in this one here that 3x cubed is not 3x to the third power. But that this cube outside here is governing everything inside the parentheses. So it is 3 squares times x cubed. Rubbishness. It is 3 cubes times x cubed. And of course, it's 4y to the 0 raised to the first power. So I didn't put that one there. This 3 is this 3. And 3x all squares is 9x squares. And 4y to the first is simply 4y. Put back the plus sign. This 3 is this 3. 3y to the first. Why am I calling it y? 3x to the first is 3x. And 4y squares is going to be 16y squares. 3x to the 0 is 1. Times this 1 is still 1. And 4y cubed is 4 times 4 times 4, which is 64y cubed. All I'm doing now is just removing my parentheses. 3 cubes is going to be 27, so it's 27x cubed. 3 times 9 is 27. 27 times 4 is going to be 108. 108 x squared y, x squared y. 3 times 16 is 48, and 48 times 3, 96, and 48, that's 144. X, y squares, plus 64y cubed. Any clearer? Have you seen?
Yes, sir.
Crystal clear now.
Great. And I really hope, and I don't, as I said before, I don't feel no way, you know. I don't want anybody to read my tone and think differently. Remember, this is the first time we're doing this topic, you know. Started this tonight. So the first question to make a mistake is not a problem. Mistake to make. That's all life is. All right, let's go. I know you would have done the second one through to the second power. I have not yet done it. So let me just let me just do it now. 2x today.
Sir.
Yes, Papa.
Get there's something wrong to get rid of fraction.
No, man, we're gonna keep the fraction, man. 1, 2, 1. No, we're gonna keep the fraction, Matthew. I don't want it to be afraid of fractions here. 1, 2. All right, so the first line would be 1, 2, 1. As I said before, the separators will always be positive signs. You'll always have plus signs in between. You'll always have plus signs in between. Always have plus signs in between. Every single time. You'll always have plus signs in between. I hear the question coming. Don't hold it back. Yeah.
If you say X in the ascending order, why you don't put this? Third, you said the question. That question you said in ascending powers of X. So why would it start at the 2x square?
Remember, sir, say no. No worry about that, you know. No worry about that yet. Worry about that when we're done the question. Because what we can do is split the something, forget the something all we want it. Yeah, so no worry about which order it look like so far. We're not concerned ourselves about that yet. No, man. We're going to done the question first, and then now we're going to fix it up. We're going to bake the cake. We don't care how the cake come out with a dome shape. We're going to cut it flat so it look like a nice piece of cake. Yeah, we soon fix it up, man. Good question, but we soon fix it up. All right. So this is 1, 2x to the second power, negative 1/2 to the 0 power. Check in. 2 plus 0 is 2. All right, well, good, sir. Then the next coefficient is 2. And if this is 2x to the second power, that means this is 2x to the first power. And if this is negative 1/2 to the 0, that means this is negative 1/2 to the first. And then the last coefficient is going to be 1. 1. And this is going to be 2x to the first. That means this is 2x to the 0. This is negative 1/2 to the first. This is negative 1/2 to the second. Then I am going to say now, what do I say? 2x to the second power is going to be 4x squared. It's going to be 4x squared. All right. And of course, negative 1/2 to the 0 is going to be just 1. And the other one is going to be, that's 2 times 2x. That's to the first power, and that's negative 1/2. And then the last piece is going to be 1/4. Look at that line and tell me if you agree. Anybody, somebody, please answer me.
Yes, sir.
All right,
Yes,
good
yes,
job.
sir.
Good
Yes,
job.
sir.
And then now oh my God. The last little piece now is me just fixing it up to say 4x squared. And it's going to be 2 times negative negative 1/2 times 2 is going to be negative 1. Times 2x. I know somebody will ask me about this one. I feel it, I sense it. Sense it. Look at what I have. Anybody agrees with that?
Yes, sir. That's what I got.
Yes, sir.
Sorry, can I explain the negative 1 and the 2x?
You remember when I said that? I know somebody going to ask me about something. You heard when I said that?
Yes, sir.
Yeah, man. I don't want them to talk about. No problem. I'm happy to. Yes, please. Go ahead.
So I wanted to ask how you know that 1, 2, 1 would be the coefficient for number 2 question.
What up here, so? Tell me what up here, so.
Okay. So if it was a 4
no. You don't answer my question yet. What is up here?
2.
All right, good. Thanks for answering. And then when I answer, you know you can answer the other question. Show me which one of them something you have 2 in it.
The third one, the third line.
This one don't.
Yes.
1, 2, 1, don't it?
Yes, sir.
Good. Let me check and see for 1, 2, 1 I have. Teacher, 1, 2, 1. Yeah. So so come in no. So ask me no if it was what now? Yeah, the second part. If it was?
So if it was 4, we would look in the Pascal
All right. Very good.
triangle for the 4.
Which one of
the
them?
4.
Yeah. So tell me which one of them is I have on 4.
The
The
fifth
one there
line.
don't. 1, 4, 6, 4, 1 don't. And the one you're going to use for the
sir.
coefficient. Yeah.
So, sir, that would
Okay,
work
sir.
if it had a 6 too.
So
If it had a 6.
we'll memorize that then, sir.
Oh, because you see a 6 right here and a 6 right here down. That's why you asked the question?
Yes, sir.
Okay. Which position I say must always look at?
Oh, the end position. The
No,
last
and let me
two.
say the second position, either from the
Oh,
left or from the right. Talk truth.
yes, sir.
We now go to the third position, and the second position you look on, the one here, or the one here, from the left or the right. So the 6 here can't work. Work. We have to use a 6 one here because this is a third, and we're only looking at number 2. So all of only want to number 2. Osh. Real talk. All right. So you can't get mixed up with this topic. All right. There is another question. Somebody asked, sir, how I get this piece right here? So no problem. So let's go right here. Let's go right here. So let's go right here. This is my 2 from the coefficient, and this is 2x to the second, so that means this is going to be 2x to the first. This is negative 1/2 to the 0, so that means this is going to become negative 1/2 to the first. All right? So this is a term you're asking me about, so I'm not going to do this one, neither will I do this one. So we're just going to work with this one here. All right? So now, this negative 1/2 to the first is the same thing as negative 1/2, I just removing the power. This 2x to the first is the same thing as just 2x as I remove the power. And this 2 is this 2. Negative 1/2 times 2 is negative 1. This 2x is the same 2x here. So negative 1/2 times 2 is negative 1. And this 2x is the same as this 2x that is right here. All right, so the person who asked the question, are you seeing it now?
Yes, sir.
And all right, we'll continue looking. So negative 1 times 2x is negative 2x, and negative 2x times a positive 1 is going to be negative 2x. So remember I said to you that the signs in between will always be positive, but it's just that now if the negative sign were to come out, they will come out. And oftentimes they come out as an alternating sign. Plus, then a minus, and a plus, then a minus. You notice that I have a plus sign, then a minus sign, and a plus sign. So you have to be very careful. You can't be careless now with squaring 2 negative numbers and get a positive, get a negative number. You can't be careless in doing that. So you have to be very particular in what it is that you're doing. You have to be very particular in what it is that you're doing. Very particular in what it is that you're doing. All right. I'm going to give you one more.
Sir, I have a question.
Go ahead.
So, sir, in the exam, seeing that this is math, if we get the answer wrong, but like they said that the working out was almost right, and you just mess up that one part, do we get most of the marks, or do we just get 0 marks, like in chemistry?
No, man. They're not really 0 marks in chemistry either.
So, like if you write the equation wrong, like with something off, it's automatically 0.
If the equation is wrong in chemistry, say you didn't balance the equation correctly.
No, sir, like if it's organic chemistry and you leave off a H or something, you're giving it wrong.
Okay, yeah, because that's a totally different compound. Oh yeah, for real, that wrong. That's a totally different compound, yeah, man. So you won't have a long chain carbon again. If you have one less something, so it's going to be a totally different something. Yeah, that's for real. But in math now, what we do is we mark something that we call consequential error, or sometimes we call it follow through. Means say, if we see where you made a mistake up top, we penalize it for the mistake right there. So, and then if the incorrect answer is correctly used for the remainder of the question, you will get marks. So the question carry 5 marks, you can get either 2 marks out of the 5 or 3 marks out of the 5, which is far better than 0, don't it?
Yes, sir.
Yeah, man. Yeah. Okay, it's now 8:21. Let me not give you anything else. I'll give you the homework. Yes, please. Yes, please.
Right there, so the second part of the answer. Yeah, there. Where that
Okay.
2 gone?
These 2, magic.
And then the half disappear also.
Hold on, the man. Yeah, but it's when we talk about magic, not real magic. I talk about, you know, real magic. All right, watch me.
Sir, did they cancel?
No, man. They can't cancel because they're not opposites. They're not opposites. All right, watch me now. You see them 2 pink one there? And then they will multiply together to give me that pink one right there. So 2 times -1/2 give me -1. And that 1 here, let me put it in a one different color so you can see say it belong to, there's something there. All right, so look at that now. You notice the blue don't change. This 2x is the same 2x right here. So
yes,
all I'm doing is multiplying this 2 by this -1/2 to give me this -1. Tell me, say see it now.
Yes, sir, I see it. Thank you.
You're sure you see it, or you just see it because you know?
No, sir, I see it.
All right, good job. All right. Are there any other questions? I mean, as I said before, can I be very honest with you? Let me be honest with you, because that's the only thing I know. The topic is finished. When I say the topic is finished because it's only 2 types that we can give you. When it is squared and when it is raised to the 3rd power. The topic finished. There's a question here that I'm going to fix up, that I'm going to send off to you to do for me. And I'm going to fix up some of these do no question. This one we do already. So I can take it out. We do that one already, don't we? 2x plus 3 right to the 3rd. 2x plus 3 right to the 3rd, yeah. I'm going to fix up these ones down here. And you call that 4. I'm going to fix up that one down there. And then call this 5. And give it to do for homework. The topic is finished. I have homework to do in order to fix up these to send off to you. The topic is finished. Those are the solutions. Watch me, solutions. And see here, this is a different area. And this piece here, so, is me wanting to show you the second way of doing the question by doing this sort of something here. Is me wanting to show you the next way of doing this something because it's still Pascal. See the formation of the triangle coming out here, so it's still Pascal, but it's just another way of doing the question. See it here, so 2x plus 3, I left off the y. 2x plus 3 equals that. It's the same question. Well, the same methodology, different methodology, but the same working out. So I do the question a different way, right? And
so,
all
sir,
of this,
if we catch the second version better than the first one, we can just use that and get the right answer.
Use whichever one you're comfortable with. Whichever one you're comfortable with, you can use it. And then now I reach my arithmetic progression. Use any one you're comfortable with. Because remember, the syllabus says, you know, the syllabus says, work with me. Tell me if I am misreading something. A plus b to the n, where a is a positive integer, not greater than 3. All right? So it means it can be 1, 2, or 3. And then now here not with 1 because 1 is the same something. Talk truth.
Yes, sir.
Right. So then we add a 2 or 3. And a and b are members of real numbers. So A and B are going to be real numbers. All right? Real numbers are fractional numbers, you know. So like Matthew I talked about, sir, we can convert the 1/2. No, for them can give fraction or something too. Then it says problems involving finding the terms or the coefficient of a term of an expansion of a linear expression such as a 1 here, 3x plus 3y to the third. Them something them I talk about. Right, while the student may become familiar with Pascal's triangle, now you are familiar with Pascal's, and notations related to n choose r, which is what I'm going to be doing next class, it is sufficient to know the binomial 1, 2, 1 and 1, 3, 3, 1. So what am I saying? Them saying that I don't have to teach you Pascal's, them saying that I don't have to teach you n choose r, them say all we can do is just show you the 1, 2, 1 and the 1, 3, 3, 1 for examination purposes only, but me not do that. Me I teach you something correctly. You can choose which one you want, but I will guarantee you, you'll recognize that both of them are almost the same and that you may want to use Pascal's more than the other, right? Not bad. And then this is finished. Well, this is already finished because I don't have to do the NCR because the question says it is sufficient. It is sufficient to know the binomial coefficient 1, 2, 1 and 1, 3, 3, 1. And I've already shown you how to get those and you know how to use that. So I don't have to do the other one, but I'm going to do it because there are a few of you, literally a few doing that stuff, but I want to give you an option. All right. So you notice that I did say to you that remember you have your test today. Based on the energy that I'm getting from some students, from the messages that I'm getting from some students, I recognize that some of you are not prepared for my end of unit test. And I'm not going to give you a test to make me get upset with my marking because of the foolishness. So hear me out now. And hear me out, put on pop up. The test is going to be about an hour long. About an hour. No more than an hour and 15 minutes. I'm going to encourage you to come to class early on Friday, God's willing, so that I'm going to begin my test at 5:30. At 5:30. 6:30, 6:45, I'm collecting my papers. And then I'm going to use the remainder of the time to just finish off with something, go through the questions, etc., and finish off. Guys, we don't have a lot of time. I can finish this topic here by next week Friday, or next week Monday, or no, I'm going to for the test. By sometime next week Friday, I can finish off this area, and I really want to move into some Kramers. As I said before, I want to get out some of the big wigs out of the way, right? I have 8 units in module 1. Trigonometry, I don't want to touch trig just yet because I don't want to scare anybody. I want to get the matrices out of the way. Then we'd have done sequence and series. Then after that, I think I will move into remainder and factor theorem, which is a very nice little something to do. We've already done unit 4, so we're on to 6. Then I may move on to 7 next. Then I will go back up to 5, which is factor and remainder theorem. So we'd have done 4, 5, 6, 7. And then I can then decide that I'm going to do inequalities, functions, graph, inequalities, coordinate. So short coordinate geometry is, so this is what I was talking about. Very short. I know this is going to be the last thing I do in this unit. Very short and sweet. And this one is short too. Numbers, right? So, and then we are. So we look like we are on our way. All right. I'm going to ask you to, I'm kind of feeling a little tired-ish, so I may not be able to generate these questions and the solutions for sure. Just it. I have 5 questions here that I'm going to rewrite for you. All right. But then again, I can just change the coefficients and then send off to you, and then I work on the solution for next class. All right. I'm going to send you the notes in a few. Start your preparations, please, for Friday for the end of unit test. Please, those of you who are having a challenge, send me a little note so we can make some arrangements to meet.
They're all going to get the test.
you're going to get the test using Editasoft. So I'm going to orient you. I was supposed to do that tonight, but I had a change of heart. So I will do some orientation with the editor. You see, those of you, no, I'm not going to get access to the thing before 5:30. We normally get the link about 5 minutes before the class time. I'm normally there early and a few students. So if those of you can come in exactly like 25 minutes past 5, I can orient you how to get it. Don't worry about it. You're fine. You're doing it online, so you're fine. All right. Good night, oh. Gentle Jesus, meek and man. Have a wonderful time.
Good night, sir.
Good night, sir.
Yeah, man.
Good night.
Good night.
Good night, sir.
Good night, dearest.
Sir,
Yes, please. Go ahead.
sir, you were supposed to speak to me. I'm not sure if you can
Sir.
hear me.
I can hear
Before
you now.
talk twice, sir. Where till we get on the test Friday? The topic.
Unit in this exponents and logarithms, everything that we've done so far. Not on this
Okay.
topic here.
Okay.
Yeah.
Okay. Bye, sir.
Bye bye, dearest. Then I was saying that I wasn't hearing you because your internet access was in and out. But I understand why it is that it's like that, because you're using data and not Wi-Fi. So I can understand. But you and I have a link before Friday, Danny. Just send me a message because we need to work
Yes,
out
sir.
how you're going to do your test. So send me a message, all right? And when you send a message, put your name there so that I can know who I'm speaking with, all right?
Wait, sir. So to work, wait, you hearing me, sir?
Yes, ma'am. Loud and clear.
Oh, so you said to work out how I'm going to do the test. It's going to be done in class, right?
Yeah, man.
Your camera have to be on.
That's the problem. That's why I said you and I, you need to talk.
Yes, sir. Because if I turn on the camera, it's going to like
Eat up the
all of the
data.
data going to go. It's going to use up the data and it's going to take me out of class.
Yeah, I know. That's why I said to you that you and I will have to talk. I know. I'm aware of that.
Oh, okay, sir.
All right. Cool. Let's talk.
Yeah.